Hello, folks. Welcome to Rational Science, the only site on the internet that does physics at all. Okay, we have a great day today. I'm gonna have to skip the extinction segment. Got enough on my plate as it is, so I think I'm gonna dig in directly. I'm gonna be doing what is it? Teleportation. I'm gonna go directly into another subject which has become relevant. And since we're beginning the year, I think it's going to help a lot just to dig into this and clarify it, for the rest of the year, so to speak, right? Okay, and that's ether. What is the ether? A couple people came over and had questions about the ether, and so we are going to address that. Let's start there. We have some problems in mainstream as well as the dissidents, the dissidents. And what is the problem? Well, they all have the same problem. And the problem is that they move concepts around. They don't even realize it, and that's, we call that irrationality. We call it being an idiot, meaning idiot being a big idea. Okay, we have a big idea. These people have big ideas, and they start moving concepts around. And so here's just a synthesis. Okay, what I'm going to be talking about: fatal problems with both mainstream and dissidents. Okay, what ignoramuses call word salad, they dismiss it as semantics, and we call it the foundations of physics. You must present the foundations of physics. You must define your words. You must present the objects. And here you see some examples. Is space-time an entity or an event? You have the black hole, you have dark matter, dark energy, Big Bang, singularity, etc. Are those things or are they abstract concept? Is a field, mass, energy, are those things or are they concepts? That's what we're getting to. That's the issue. And these people treat them as things. They reify all these concepts. They are concepts. They reify them. But the dissidents, although these dissidents, they do the same thing. People like the electric universe and etherists and flat earthers, all these people who object to the establishment, to the mathematical established in mathematical world out there that rules the waves, right? And what do they move? Well, they move electricity, plasma, and ether. And the question is, these words represent objects or concepts. Okay, that's the issue. Concepts we define, and things, we point to. We have to point to things when you present them, especially in physics. And what is a thing? An object, a medium. What other words can we have? Stuff, entity, whatever. It's that which has shape. Okay, that's what it is. All objects have shape. There's not one that you can even imagine that doesn't have shape, but if you do, please let me know. I want to know if any object that doesn't have shape. It's a universal property of all objects have that. And concepts we define. We can't point to concepts, because a concept is a relation between two objects, really. Okay, so and so we move there and say, whoa, went out of focus here. See if I can get myself back here. Sometimes, give it some time. There he goes. Jesus, more or less. Hello. I hope you can hear me fine also. Okay? And I'm still not in there completely. I don't know why I went out of focus. There we go. Okay, got myself back. Anyways, it's irrational to move a concept. It's irrational to say you're going to move running or flying. You can't move what's already in motion. Okay, aside from the fact that it's not an object, it's not a thing. What are you seeing? Motion is two or more locations of one object. If you don't have an object, if you're talking about a concept, then what's moving? So you need an object. And for physics, you can't start without. Imagine there's nothing in the universe. what are you watching? What's happening? And so the first step of the scientific method has, or you can say the first two steps. One is to present the objects. You have to present the object. You have to point to it. And the second one is that you have to have definitions, solid definitions for the key words, the ones that make or break your theory. And if you don't have those two things, you can't even start. Nobody wants to listen to your theories because they have to be garbage. Okay? The only way you can present a rational theory is by beginning to make sure that you point to the objects and that your definitions are sound. Then you can start, explaining whatever you want to explain. Then people can follow your presentation. Okay, so that's the starting point. We call it establishing the foundations of physics. Okay, so what do we call these people? We call them idiots. Okay, what is an idiot? An idiot is someone who attempts to move concepts. And we know most of the ones that they move in mathematical physics, in the establishment, black holes, dark matter, all that stuff. But then the dissidents, they usually work with these words, the ones that are in the little rectangle there, red rectangle. Plasma, electricity, the flat earthers love the word density. Ether, a lot of the electric universes also move ether or are etherists. Right? And just about everybody in mainstream and the dissidents, they all move the wave. They wave the waves. And yeah, an idiot is a person with big ideas. Okay, that's what an idiot is. And they are irrational people because they never define their terms and they dismiss all this stuff as, they call it word salad, word wizardry, or semantics. They say, that's not important. I want to do physics. Well, if you want to do physics, you absolutely must have objects and solid definitions. So you can't elude that. And here's just a synthesis of the people in the electric universe, okay? The thunderbolters, thunderbolts are the gods. And what they propose is electricity, right? And they start moving the electricity, even though it's already moving, according to them. They don't know what electricity is. The best definition they have is that it's the movement of electrons from atom to atom. And of course, by doing so, what they're actually invoking is the planetary model. Okay, so if the electron bead that is orbiting the nucleus is moving from atom to atom, what they're invoking, what they're using essentially is the planetary model. Okay, then they also propose this nonsense called the fourth state. Plasma? I thought the fourth state was Georgia. And, these people say it's plasma. I didn't even know there was a state called plasma. Anyways, these are the words they use, and they never define them. They don't realize that plasma, as it relates to matter, is not a state. See, solid, liquid, and gas, you don't need to have any motion. So they are static. They are states. Whereas plasma is always in motion. It's ionizing. It's in the process. It invokes, and it embodies motion. The word plasma already embodies motion, whereas solids, liquids, and gases do not. So you have ionization constantly going on. You can't have a state known as plasma. Plasma is not a state. Okay? And again, Georgia is the fourth state, so I don't know where they got that. Plasma is the fourth state. No way. Okay, so that's our starting point, just in general terms. And one fellow came over and he said the following. He says, "You want me to draw the ether?" That's what we said last time, that people should draw the ether. And he was one of the ones who replied to this. And he says, "I can draw you some ether just like you drew me your ropes, okay? I can draw you some kind of medium out of my mind, just like you drew the ropes." Good. That obsession of yours is ridiculous. What will that serve? I don't know what ether looks like. Oh, he's already confessing. Any more than you know what your threads look like. Okay, let's find out. It's all supposed to be invisible and intangible, remember? Okay, not being good at drawing stuff. Okay, so he's saying he's a poor artist, I guess. Doesn't mean that it doesn't exist. Okay, that's all very childish, Bill. Do you know what air looks like? Okay, so he threw the glove in my face. So we're going to address that. We're going to find out if any of his arguments have any merit, you know. So we do have to start with the scientific method, which is essentially what the main point of today's lecture is about concerning ether. It's these people are not in tune with the scientific method. That's what it's all about. And so here, let's present the scientific method. What is science? Rational explanations. If it's an irrational explanation, it is not a part of science. And we're not going to go over what rational explanations is. We're just going to say for rational that movement of concepts is irrational. Okay? And so what does physics deal with? One of the two branches of science, it deals with objects, and it tries to explain causes and mechanisms. That's what we do here primarily. Okay? And there you see on the right, the rational scientific method. And it includes the first step there. That's the one we're interested primarily today. Known as hypothesis, also assumptions or suppositions. And you need to present the objects and the definitions. Those two are sine qua non. You must do those. Okay. Definitions form what we call the foundations of physics. Okay. So you have to have some key words. Object exist, location, distance, motion. Those words have to be defined because you're going to use them to explain. What do we explain? Causes and mechanisms. Okay, and then you move on to the initial scene, which is the first scene, the first frame, or in the Universal movie. Okay, everything's static there. You just point to everything in the screen or wherever, whatever props you're using, and then you move on to tell your theory. Okay, so that people can follow your presentation. That's a logical way of presenting all this. You point and you say, this is a horse, that's a buggy, and I'm going to explain how the buggy moves from A to B. And you put the horse in front, you time to the buggy, and the horse moves and takes the buggy with him. That's an explanation. Everybody can follow it. Everybody can see it on the screen. You can fill in the blanks wherever needed. You can explain what they're observing and you can explain why the cart moved from A to B. Okay, that sort of thing. And that's the way we want everything in science. We want to be able to explain things in that way. And we don't have that in science. And in fact, nobody can explain in quantum mechanics and in general relativity and in string theory, they can explain why this falls to the floor. And that's the only experiment we ever needed for gravity. We need to know what's the mechanism that Mother Nature uses to make this pencil fall downwards. Okay, that's all we want to know. And these people are out there saying, well, let me tell you, it's warp space, warp time, and there's a hologram on a black hole, and what's that got to do? I just want to know why this falls to the floor. That's all. Why does it fall to the ceiling? That's all we want to know. Understand? Well, okay, so what if we had no objects? What if we remove all objects from the universe? Well, then you get something like this in the Universal movie. You would get nothing in each one of the frames of the film. Okay, so not much happening there inside the film. You're not watching anything because there's nothing there. If you want something to happen, you must put objects. You can't do physics without objects. That's the first rule. Okay, so you absolutely need an object. And these people have never realized that you need objects. And so they work with concepts. They say, oh, the field, oh, energy, and they don't realize that all these thingies that they think are thingies, stuff, right? They're all concepts. Field, mass, energy, time, it's all concepts. Wave, all those are concepts, okay? And if you want to have something in there, you have to do it like this. You have to, let me do this. Give me a second here. You have to have that. You have to have objects in each frame of the movie, okay? So on the left, you'll see maybe the universe, the stars, whatever, and somewhere in the center, you see the rock, a tree, and maybe a dog jumping on the next frame. So you have to put objects. Then people can follow your presentation. They know what you're referring to when you say rock or tree. Okay, that's the way it works in science. If you're going to explain a mechanism, you had better have objects. You can't do mechanisms without objects. You can't do physical interpretations without objects. That's the point. The word physical, that's an object. Okay? And so here we see the difference between an object and a concept again. There's only two categories of words. Every word in the dictionary falls under one of these two categories. It's either an object or a concept. Okay? Now you might say, oh, I know of a third or a fourth or a fifth category. I don't care what category you introduce. I'm going to put them under one of those two for sure. It either has shape or it don't. It's black or white. Yes or no, on or off. Okay? Either it has shape or it doesn't. That's the way it is. And that's the first rule. The second one is that object is that which has shape, whereas concept, the definition of the word concept is a relation between two objects. It's a word that invokes or embodies two objects. That's what a concept is. So you're establishing a relation, a comparison, a contrast between two objects. That's what a concept is. Okay, so every word will fall under one of those two categories. Either it's an object or it's a concept. There's no in between, no third category in the dictionary. Okay, and there you see some of the synonyms. And the first one is medium. I'm going to use that word medium because a lot of these etherists, they believe that they use that word medium. They think ether is a medium. And they don't realize what they're saying is that ether is an object, a thing. Okay, so medium is a synonym of object. Medium is a synonym of thing. Okay, so medium is what? That which has shape. That's the definition of medium. We don't care if it vibrates. We don't care if it moves. We don't care if it's made out of particles. It has to have shape overall. So whatever you present for ether, you better be able to point to it and say that blob there, that ball, that cube, whatever you point to, that's got shape. And if it has shape, now we can begin your presentation. You can't say, well, I don't know really what it is, and it's something that's flowing, and I don't know where it ends. I've never seen it. I don't draw very good. None of those excuses will work. You have to point and name and say ether. That's how we do it in science. Okay, and there you see the synonyms for concept. Okay, we point to objects and we define concepts. You can't define an object. You can't define the word table. You point to a table, then you can describe it if you want, but for the ET, for the Klingon to understand what you're talking about, he has to understand your language. You say table, he says, I don't know what table is, and you point and say, that's table. And you point to a table, you point to a chair, you point to a tree, you point to a rock. Then now he understands what the noun refers to, what that word refers to. Okay, so the nouns you point to. That's the way it is. And the nouns of physics are not the same as the nouns of ordinary speech. Motion or orbit are nouns in ordinary speech. In physics, they are verbs. Okay, so you can't point to motion, you can't point to orbit because those are verbs. Okay, there's a thing, they're motion. Essentially, that's what they embody. Okay, so here we have. Let's go with this fellow, go piece by piece. And he says the following. He says, you want me to draw ether? Yeah, I do. I can draw you some ether just like you drew me your ropes. Okay, do it. Very simple, huh? I can draw you some kind of medium out of my mind just like you drew ropes. Okay, and there I drew my rope. There you see the rope. In fact, I can do even better than that, a little better than that. I can show you a rope. Here it is. This is a rope, 2-strand rope. Okay, it's one twined around the other, 2 strands, or whatever you want to call it, strings, threads. Okay, so we have one wound around the other. Okay, so this is what I call the rope. And if you don't believe me, you can go to the hardware store and ask, for a 2-strand rope, and they'll give you something similar to that. Okay, that's the way it is. Okay, so you shouldn't have any problems understanding what a rope is. Okay, but apparently this guy, I don't know if he's taking English as a second language, ESL 101. Maybe he doesn't know what a rope is, but there I'm illustrating it for him, so he shouldn't have any problem understanding what a rope is. That's what we're proposing is this entity that mediates both gravity and light, what we call the grand unified theory or theory of everything, right? Okay, he says, that obsession of yours is ridiculous. What will that serve? Well, it'll serve 2 things. First, it'll determine whether you understand the fundamentals of physics, okay, whether you took Physics 101 in your life. And the second one is show us what going through your mind when you say ether. I want to know what you are thinking about when you say ether. So I mean, if you say that you've never seen ether, you don't know what it looks like, then we don't know what's going through your mind. You have to tell us what your God looks like. I don't care if it's the real God. We don't care about that. We want to know what your God is because you're giving us an explanation. You're giving us a physical interpretation. You might say God created the universe. No problem. That's the theory. We want to know what God is. We still don't know what God is. What do you mean by God? And so you first bring God and point to him and say, that's God. Okay, now we know what you're talking about. Now you can do whatever you want with God. But to say, God, I don't know what he looks like. I've never seen him. I just believe in him. That's no good. Not in physics. You have to present the object so we know what you are talking about. We don't care what God is in reality. We want to know what's in your mind. Same with the ether. You got to tell us this is the ether. Okay, so now you point, you show us the ether. Now you can move it, you can vibrate it, you can do whatever you want. You can make it flow or make it fluid, whatever. You can do whatever you want. But the first step is show us your ether. You can't just begin in the middle of your movie and say, it's moving. What's moving? We haven't seen it yet. We don't know what's moving. Okay, so this is the issue. And this is the problem with all ethers, okay? So here is the ether, okay? That's what the ether has always been, a bunch of particles, and those particles vibrate. That's what they always thought in the 19th century especially, okay? That all those particles are vibrating, and they create these waves, which they call light. And supposedly there were two individuals, Michelson and Morley, that proved that there is no such thing as the ether. And so all these people are in a war against Michelson and Morley, saying, well, that's not what they really proved, and blah, blah, blah. Well, we don't care about Michelson or Morley or you. Anyone who talks about the ether, the first step is to present the ether. And these people never do that. And Michelson and Morley didn't do it either. None of them. All the way to Fresnel in France, Faraday, Maxwell, none of them ever knew what the ether was. They never pointed and say, this is the ether. Now let me tell you something let me move it or do whatever with ether. No, they just began talking and say, oh, the ether, like we all know what it is, don't we? No, we don't. Please show us. And that's where they all failed. They all failed that. Okay, so where do we move from there? Well, here we have the same fellow. He goes with the second part, and he says, I don't know what ether looks like. Well, that's great. So he doesn't know what it looks like any more than you know what your threads look like. What do you mean I don't? There's a thread, and you got it illustrated there. In fact, I'll, again, do you one better and show you a thread. This is a thread. You never seen a thread? It's really my floss. But that's a thread. That's called a thread, okay? I don't know what's so difficult about understanding what a thread is. I do know what a thread looks like, and that's what we're saying is that what underlies, all matter in the universe. It's a closed-loop thread. It looks like this, more or less like a rubber band, okay? So let me show that again, I guess. Okay, it looks like that. That's what we're saying, that if you untangle every atom in the universe and every rope that interconnects any two atoms, you eventually end up with something like that. There's a closed-loop thread. What part of that this fellow doesn't understand, I don't know. Again, maybe he's taking ESL 101. This should be straightforward. It's kids stuff, baby stuff. I'm not talking about here rocket science or anything. I'm just telling him, what it is. So yeah, the thread there, you see a picture of it. So hopefully, everybody understands what I'm talking about. I'm talking about a thread. What's so difficult about that? And yeah, so I do know what my thread looks like, but you haven't showed us what your ether looks like, okay? And he says it's all supposed to be invisible and intangible, remember? Well, there's no provision for tangibility or invisibility in the word object, in the word thing, in the word thread, right? Thread is that which has shape, and there you see the shape. That's what a thread more or less looks like, okay? So an object is that which has shape, not that which you can touch or see. Okay, so don't use invisibility or intangibility. Don't bring it into the question, into the issue, into the discussion, because it's got nothing to do with it. Okay. So this fellow, I don't know, he still doesn't understand what he's supposed to do here, apparently. He's supposed to illustrate the ether so that we can see what he's going to vibrate, what he's going to flow or make fluid or whatever. We need to see it first. Then he can move, he can present a flying carpet for all we care, and then said, now it waves. Fine. No problem. We understand because now we see the carpet. But you can't say the ether, and I don't know what the ether is. I've never seen it. I cannot imagine it, but it flows and it vibrates and it does all these good things. No, that's not the way it works. Sorry. Okay, so he continues and he says, do you know what air looks like? Well, the first issue is the question is not what is the shape of air. That's not the issue. The issue is, does air have shape? Okay, that's the question you should ask. It's a yes or no type of question. So that's the first thing he did not understand. So he thinks it's a question of what is the shape of energy? What is the shape of mass? What is the shape of a field or whatever? No, the question is, does energy have shape? Does mass have shape? Does time have shape? Those are the questions that he's got to answer. And so when you say ether, we're not asking what is the shape of ether. What we're saying is, does it have shape? And if it has shape, you should have no problem drawing it or illustrating it, sketching it. We don't need a perfect version of the ether. We need something in front of our eyes with contrast. Okay, that's, contrast giving you a contour. Okay, and here's, since he didn't know what air is, here, let me show it to you. Okay, here we have an astronaut. Okay, he's taking a balloon and it's got air in it. In fact, he can have any gas he wants in it. Doesn't really matter. So he goes out there and he pops the balloon and out comes the gas. Could be air, it could be xenon, anything. Okay, so we've got air there. We color coded it white so that you know what we're talking about. And the question is, does, not what is, but does that white stuff have shape? Okay, that's the question. And if it has shape, it's an object. It's a thing. Okay, in fact, anything made out of atoms had better be a thing, had better have shape. Okay, and so yeah, air does have shape, and he never figured that out. Very simple things. Okay, and here you have a more realistic scenario. Okay, here you have the Earth on the left-hand side, and we can't see the air, so we make it visible right in the center, and you see these different layers of air. Okay, and then we remove the Earth from right the center, and what you end up is that this is a 2D version, so you see rings, but you're supposed to look at that as if it were shells, different concentrations of air. The closer you get to Earth, and less air as you go out, to the point where you see that black stuff, and that's no air over there. So you go from what someone raised the other day, which is we go from an area where you have no vacuum to an area where you have vacuum. Okay, so it goes from no vacuum to vacuum. And yeah, you can have no vacuum next to vacuum out there in space. In fact, we do everywhere, around every star, between every galaxy. There you have vacuum next to matter. Okay, so yeah, if you want to know what air looks like, there you have it. It looks like that, more or less. Okay, there we illustrated for you so that you know what air looks like. Okay, air does have shape. That's the point. And again, it's not, we don't need to draw it perfectly, just we get to convey the notion that anything made out of atoms, such as a gas that's covering the Earth, had better have shape. Okay, whether you can see it or not has nothing to do with it. Okay, you're supposed to say, well, if it's made out of atoms, hopefully it it has shape. And here's the flat Earth version of that. I guess that's how air looks like in the flat Earth society. I don't know. Okay. Okay, maybe someone from the flat Earth can clarify that for me, what air looks like according to them. Capsulates the Earth. There you see it. Okay, here's the 3D version of air around the Earth, more or less. A picture that you see there. Okay, and in fact, here's another one. Okay, looks more or less like that. So use your imagination as much as you can. to visualize what air looks like. Okay. And here's a kindergarten one, I think. I found out there, layers of Earth, atmosphere. So you see the Earth and you see these different layers of air or atmosphere or whatever. So yeah, all this gas does have shape. It looks like if you had the eyes of God, it would look like shells around the Earth. So should be no mystery what air is, what any gas is for that matter, okay? So let's make sure we understand. All gases, same thing. They're made out of atoms. They had better have shape. What shape do they have inside a balloon? It has balloon shape. What has it? What shape does it have when the astronaut pops it out there in space? Well, some kind of blob. But that blob hopefully has shape. All blobs have shape. Okay. It's not a concept, it's an object, a thing. Okay. So yeah, liquids and gases, they all have shape. They're all objects, they're all things. And these people never realize that. They talk about the word medium, but they don't know what the word medium means. They think ether is a medium, but doesn't have shape. Yeah, sure. Tell me about it. And then the last point he made was that he's a lousy painter. Okay, I can't do much about that. He says, not being good at drawing stuff. Well, that's no excuse. We don't care about, get someone else to draw ether for you or point to it somewhere on the internet. I mean, the ether has been around for thousands of years, right? Since the days of the Greeks at least, if not earlier. And so the question is, what picture do we have of ether out there? Look them up, and I've shown what it looks like. It shows like a bunch of particles. That's what it is. Bunch of particles. That's what they always illustrate for the ether. So that's what the definition of this concept is. Bunch of particles. And he says, that's all very childish, Bill. Yeah, it's childish because you can't do it. Because you're using excuses to weasel out of the requirement. And again, it's a requirement not of Bill Gates, it's a requirement of the scientific method. Scientific method absolutely requires that you present the objects in physics and that you define your terms. We point to objects and we define concepts. Okay, so let's go slowly because these people are very far back in their education. Physics education. Here's, we have hearts and we have love. Is love a physical object? Is heart a concept? And I think it's the other way around. Heart is a thing and love is a concept. Usually, that's the way we see it. So here we have a heart. How do we present it? Well, first we present the one on the left, which is a static image of a heart. And then we move to the one on the right and show how it moves so we can show maybe how a heart pumps blood or whatever. Okay, so first you point to the static object, then you put it in motion. Okay, very easy, straightforward. Or do we need any more, spend more time on that? I think this is kindergarten stuff, but it is for me. I don't know, maybe these people are struggling with all this stuff. Okay, so here we point to love and we point to heart. Can we do that? Well, you can point to a heart and say, if you're going to use it, to say that a heart moves mountains, right? You can do that. But you can't point to love, first of all, because it's a concept. All you're pointing to is letters there. And you cannot say that love moves mountains, not in physics. You can say a heart moves mountains, but not love, okay? And you can put the heart in motion, okay? Here it is. And show it's pumping blood. You can attach whatever you want to that, but you can show the heart expanding and contracting, even though that's not the real shape of a heart. You say, hey, this is what I'm going to use as a heart for my presentation today. Okay, and so you have it pump and you want to explain how blood is pumped by the heart. But you can't do that with love. What are you going to put for love? We're going to put the letters moving? Is that what you're going to do with this concept called love? Okay, so this is the issue. The issue is that these people, they want to move concepts around. And again, first you have to determine what is a concept, what is of an object. Then if it's an object, you have to illustrate it. So if you say that ether is an object, no problem. We have no problem with that. But present the object. Put it in front of us so that we can see what object you're referring to. And if it's a concept, then you have to define it. Okay, because you can't point to a concept. And you can't put a concept in motion. So if you're going to use ether as a physical object, as a medium, as you call it, hey, then you got to illustrate it. It's an object. You're treating it as an object, not as a concept. Okay, so words are very important. It's what all these people call what they call it word wizardry or word salad or semantics. Yeah, they skip this stuff because they don't think it's important. And then they wonder why there are no explanations for gravity today. Yeah, there are no explanation for gravity because all these people are using concepts as physical objects. They're moving concepts around. They talk about energy, mass, and field, charge, and whatever, and time, and none of them have anything to do with physics. Okay? None of those belong to physics. They're absolutely concepts, and they are mathematical concepts specifically. Nothing to do with physics. Okay, here again we see a motor, okay, and maybe I should put these the other way around. Give me a second here. The one on the left is the one you have to present in a static mode, and then you put it in motion on the right. You explain a mechanism, how a machine works, how a motor works, how an engine works, right? So that's the way it's done in physics. First you point to a static image of it, and then you put it in motion. Okay, you can't begin by putting it in motion from the start and say, the ether is already flowing. No, don't make it flow yet. The electron never stops. It's always moving around the nucleus. No. Please show us the atom in a static mode first. Then you can move the electron, the proton, whatever you want to move. First, show us a picture of your atom. Then you can do whatever you want with it. And of course, they can't do that because as soon as they present the planetary model, Bohr, Rutherford model, what are they going to put? They're going to put a ball in the center and a little ball on the side. And they always draw this dotted line, this circle around it, around the atom. And what does the circle represent? Motion. So they're trying to embody motion in the picture. That's not allowed in physics. You can't do that. If you're going to present the atom, this is what the quantum atom looks like. Here you have the proton, here you have the electron. You can't show it in motion. You have to show it first like that, one next to each other. And you say, well, that's not true because, the electron's always moving. Well, we'll have God, the devil, or whoever, out there who's a magician, stop the universe, freeze everything so that nothing moves. There's no motion in the universe. We want to see a single frame of the universal movie. What do we see in there? We just see a ball and another ball. That's their model. Okay? And of course, if that's their model, they would have to explain what prevents the electron from flying away or falling into the positive nucleus, right? Okay, another thing we have to clarify is that we do not put verbs in there. Okay, and again, what I just said more or less here, I'm reinforcing that. Here you have Mona Lisa, and people say, well, that's her smile there, Well, I don't know if that's her smile. Is she smiling or not? Well, you can't synthesize smile in a picture, okay? Smile is a verb, so there's better be some motion when you talk about smile. You can't take a snapshot of a smile, because if you take a snapshot or draw a picture or whatever, paint a picture, and you put her and you say, that's Mona Lisa smiling, well, I don't know, because I don't know what frowning is. I don't know what straight face is, what her normal face is. So I don't know if she's smiling. For that, I would have to have a comparison. I have to see a change in her face. In other words, I would need something like this, okay? Here you see it? Okay, you have to see Mona Lisa moving. Then you can see her changing her face or whatever. And then you say, okay, I see what Mona Lisa is doing now. She's smiling, frowning, she's moving her face. Now I can understand frowning, I can understand smiling and any of those. And what we do is if we stop it like there, then you can figure out what frowning is, but only if you have a comparison. You have the normal face in the center, you have frowning on the left and smiling on the right. Okay, now you can talk about smile and frowning or being angry or whatever. Those are verbs. You cannot synthesize a verb in a picture because you're assuming too much. You're reading more into what's in there than what's in there, What you're saying is that you have already a memory of her with her normal face, and now you're going to see her smiling, okay? Because you're already assuming too much. It's not in the picture. You can't show the ET or the Klingon, you can't show them smiling in a picture. As far as he's concerned, that's her only face. And if you want to see her smiling, well, you have to see before and after. Then you can see it. And for that, you need 2 frames of the movie. Okay, so you cannot synthesize smiling in a single picture. Okay, so what do they do it in? How do these ether is proposed? Well, they show you something like this, or this is what they describe because they can't do anything else. And they show you something like this, or this is what they have in the back of their mind, or this is what they're describing to you for you to visualize because they never illustrate it. So they show something like this, okay? And they say, that's the ether. And you say, well, what am I staring at? I mean, what is that? Well, let me explain it to you. No. I don't want to listen to your explanation. I want to see the ether before you move it. This thing is already in motion, and apparently it's infinite because I don't see the edges of it. The only reason it has edges here is because, the frame is around it. But other than that, this thing continues forever. So when they say, oh, the ether, I don't know what it looks like. Well, you don't know what it looks like because you're assuming, or you're essentially stating that it's infinite, that it has no end, that extends forever, even beyond space-time. It's forever. There's nothing around it. Okay, so that's what you're saying. And that's the same thing the people that propose space-time are saying. They're saying space-time. Well, where does it end? What does space-time look like? And they say, well, I don't know. I've never seen it. It's a 4th dimension. I can't even imagine it. Well, I mean, again, they show you this tesseract, and they say that's a 4th-dimensional cube or whatever. Well, if that's what's on the outside, I want to know what's giving it shape. How come this tesseract has shape? Or the hypersphere, why does it have shape? What's on the outside? And they say it's an invalid question. You can't ask that question. Yeah, because they can't answer it. That's why they want that question. Okay, so what do they see it? They see it as a fluid that's flowing like a river. And again, I put the frame there, okay, the yellow frame, just so you know that river continues forever. And so this is how they present it. I'm saying, well, you went too fast. I need to see it stop. I need to see all motion stopped, okay? And so now we see the ether without any motion, if this is what they're proposing, right? I'm trying to put words in their mouth because they're not putting the images. So I'm putting the images here. And they can criticize any image they want. No problem. But then they have to put something in exchange. They can't just walk away and say, well, you got it wrong, Bill. No, I know I got it wrong. I want to know what's right. So don't tell me I'm wrong. Tell me what's right, okay? And so here's a static image of the ether, of that same ether. And the question is, does it extend forever, okay? And yeah, this is one of the questions they have to answer, because if it's an object, it can't extend forever, because an object is the opposite. It has shape. That means it has a boundary. And there's something outside of it giving it, contour, or providing contour, contrast, or whatever you want to call it. And so that's the way you got to present the ether. You can't say the ether extends forever, because that's not an object. It's a concept. And for that, now you need to define it, and you cannot use it as an object. You cannot say it moves, it vibrates. You can't do anything with it because it's a concept. Okay? That's the way it works. It's called word salad. It's called semantics. Bill, you're doing semantics. Yeah. Semantics is the first step of the scientific method. It's 150% of science. If you're going to give a physical interpretation, in physics, you had better do semantics. Okay, so here we move on and move to make a little comparison here. You have the infinite medium. And again, I put a white frame around it just so to chop it off. But you have to think that all those particles that are moving there, they extend forever. And then here you have a finite medium, okay? And the issue here is not, what are all those dots? We don't care about that. We care about the overall shape of this finite medium, and we care about the contrast. What's the black stuff? Those are the two things you have to identify, okay? So here we stop the motion. That's the first thing we had to do, okay? So we stop the motion there, okay, so that you can see it in one shot, no motion. And we don't care, again, about the particles, okay? As far as we're concerned, this is what we're staring at, okay, which is just a ball, okay? We don't care what it's made of. We don't ask, what is the table made of? What is the elephant made of? We don't care about that. We just point and say elephant. We point and say tree. We point and say rock. That's the way it is. Here we point and say ball, if that's what you're proposing for the ether. And of course, the thing you're going to have to worry about is that contour. What's that black stuff? I need to know what the black stuff is. And if that's ether, the orange stuff is ether, no problem. Then we need to know what the black stuff is. Okay. And then you can begin to do your presentation. Now we know what the ether is according to your way of thinking. Okay. And yeah, here we have two examples again with the infinite particles, and they put them in some kind of motion. They say, oh, they're vibrating. And in the other one, you have a finite one, and they say it's fluid. Okay, and no problem there, because the first one, the one with the yellow frame around it, that's supposed to be infinite, and so that's not an object. Whether it's moving or not, we don't care because they haven't presented the object yet. If it's infinite, it's not an object. And then the one on the right is also fluid, but here it doesn't have a frame around it. In other words, that orange, reddish thing, looks like a carpet, that stands alone. But then again, we have to know what the white stuff is that gives contour, that provides backdrop to that red rectangle. Okay, so no problem in looking at that red rectangle and saying that's the ether, no problem, and that it's moving, it's made out of a single piece, no problem there. The only problem here is that we need to know what the white stuff is. Okay, you have to identify the white stuff that gives contour to it. The other one's not even an object, it's a concept because it's infinite, so it doesn't qualify as an object. You have to, the yellow frame is artificial. I put it there because, I can't present an infinite object for you. Sorry, no such monster. All objects have shape. The one on the right, the red one, has shape, but we need to know what the white stuff is. And so you do have to tell us, what the backdrop is, okay? And so let's look at some of the conclusions here, okay? Ether can't define the ether because it's a concept. And so they don't want to define it as a concept because they want to use it as an object. That's the problem. And they can't point to the ether, meaning, the shape in front of us, contour or whatever. Why? Because they say it's infinite. Usually, they imagine it to be infinite. Yeah, and they don't always state that. Sometimes they say it's the same thing as space. Sometimes they say the ether contained within space, like if space were something different than the ether. And so we have these contrasts, these contradictions between all these ethers. That's one problem. But yeah, we need to know whether ether is an object or a concept. Concept, we define. Object, we point to. Very simple. And if you point to it, we need to know what the backdrop is, what serves as a contrast. Then ether, they like to live with all these dualities, contradictions, paradoxes. It's they want the medium, this thing called ether, to be both a medium, an object, and a concept. So they use it as both. Just like the space-time, by the way. Space-time, that thing that warps, that's called gravity. Okay, so is space-time a physical object? Well, it's an object, it's a concept. It's both. See, and what is light? Well, it's both. It's a wave and it's a particle. So they have all these dualities. They put them in there because they want to cover all the bases. They want the best of all worlds. That's why they put them. That's why they never differentiate between concepts and objects. Okay, that's the problem. And you have to tell us if it's infinite or finite. If it's finite, it's an object. But if it's infinite, it's not an object. It's a concept. Okay. Ether, a lot of people say it's unimaginable. Why? Because they want to put it beyond your reach. They don't want you to criticize their God. They pray to the ether and they say, oh, you're going to tear my ether apart. That means all my theories go down the drain. I'm not going to allow you to do that. So I put it beyond your reach. I don't know what the ether is. I can't draw it because I don't know how to draw very good. They come up with all these excuses. No, you must, absolutely must illustrate your ether if you're going to use it as an object, as a thing, as a medium, as an entity, or whatever you want to call it. All those words are synonyms in physics. Okay, and so they do a flu-flow. Flow. She sells seashells by the seashore. How many much wood would a woodchuck chuck if a woodchuck would? Okay, I think I'll recover myself. I'm okay. A flu. Yeah, it always a fluid that flows and a flowing fluid. And yeah, and they also want it to be static. So you have both worlds. Again, some people say it's static. The other one says, no, it's moving. And so they haven't figured out what the ether is yet. Okay, so again, you have to determine whether ether is an object or a concept. If it's an object, draw it, then you can move it and flow and fluid and do whatever you want it. And if it's a concept, you can't use it as an object at all. You just define it, and I don't know what use you're going to give it. Okay, yeah, so it's unimaginable. Put it beyond your reach, okay? Ether is against the scientific method, the way it's used today, okay? And the way it's always really been used, because they've always used it as a bunch of particles. That's what it's always been. Infinite particles. That's what ether has always been. And they're always vibrating. You know, it's not a sandbox like static. They're always vibrating, okay? And some people say, well, it's a sandbox, which is what Michelson and Morley essentially assumed, that it was like a static bunch of particles out there, like a sandbox, and light was moving against the sandbox. So I don't know what they had in the back of their minds when they did that test. It would have been simple for Michelson and Morley just to say, look, that's the ether. And once you point to the ether, you say, okay, now I know what you're going to test. Right now, we don't know what they tested. We don't know what they had in the back of their minds when they did their experiment. Okay, so ether it's an irrational individual. Why? Because, it's not part of science. Unless they can show us what the ether looks like, it's not part of science, not part of physics. Okay, physics requires an object. Okay, and again, science, rational explanations, physics, rational explanations of causes and mechanisms, and you can't use concepts as objects. Okay, that's what's irrational. So we have a definition for what rationality and irrationality is, at least one of the criteria. There's a couple more. Okay, how about us? The threads, the single thread. Do we do the same thing as the etherists? No, we do something a little bit different than all of them. Mainstream and etherists and electric universers and flat earthers and all these other people. We're the only people on the planet Earth that do this, okay? So just in case you happen to drop by here. That's the single thread. That thread is the one that's going to turn into everything. It's going to turn into atoms connected by electromagnetic ropes. In other words, a pair of twine threads of that same stuff. Move on to another atom, constructs that atom, continues on the other side as a pair of twine threads, continues to another atom, and so on down the line, from one end of the universe to the other. There's a single thread in the entire universe. That's what we're proposing. And the object is a single thread. There you see it. I hope everybody can see a shape there. Now, we put it in motion, but obviously we can stop it and you can still see that thread. And again, for those who want to play devil's advocate, it looks something like this. Okay, I don't need to move this for it to be a thread. Okay. It's a closed loop thread. Essentially, that's what we're saying. Okay, you can see it. There it is. That's all there is in the universe, according to what we propose here. That's the assumption. Okay, and that thread turns into this. Okay, it goes from this closed loop to twine threads. It twines around itself, around the entire universe, really. Okay. And you can see how the more it twines, eventually it turns into atoms connected by a pair of twine threads, which we call a rope, okay, because that's what it looks like. We call it a rope only because it looks like a rope, like one you buy, a two-strand rope you buy at the hardware store. And then from there, you can see all the atoms in the universe, they're all interconnected. So the atoms are made out of the threads, so are the ropes that connect them, the two pair of twine threads, and all atoms in the universe are physically connected. They're interconnected. Okay, so I think it's very straightforward. For those of you who want to ponder this assumption, and from there construct the theories of light and gravity. Okay, so here we have this same fellow, and he goes in there and he says, because of this, because he thinks it's all of this is word wizardry, word salad, semantics. He doesn't realize that the establishment is doing that to him, and that's the problem that he's got really with what they do in the establishment. It says here, space-time is a mathematical reification, has no material properties. Yeah, tell them about it. They say that gravity is a warpage of space-time. Space-time is a bunch of, what, number lines? And they're bending the number lines and they're telling you that's gravity. And so this fellow says, well, it's a metric in physics. A metric is a numerical value derived from measurements, et cetera, et cetera. Space-time is a number, a quantity used in the field equations of general relativity, not a material which can bend, curve, or warp. Well, then why do they say that, space-time warpage is gravity? In other words, they're saying that the Earth doesn't fly out of the solar system because there's a physical object that's bent, that's warped, and prevents the Earth from flying out of the solar system. The Earth or the Moon, they go around a depression that looks, the whole mechanism looks like the roulette, okay? And that's what they're explaining. They say, look, you have this roulette mechanism, you have a depression, and the Moon goes around the Earth, and the Earth goes around the Sun. Why don't they fly out? Because you have this depression, this wall that prevents the Earth from flying out. And what is that wall? It's space-time. And space-time, what is space-time? It's a pair of coordinates, really a pair of number lines, four of them, really. Okay, so you have number lines. And so the mechanism they're telling you, physical mechanism, is that these number lines are preventing the Earth from flying out. And then you say, well, they're really using a euphemism or a way of speaking. It's just a manner of speaking. And really what they're saying, they're giving you a mechanism. So you can't say it's just a matter of speaking, a euphemism, or a figure of speech. They're actually telling you in your face that that's the mechanism that their mathematics proposes. So he leaves them off the hook. He says, well, it's okay because they're just using poetry, and we don't really believe the poetry, but that's the mechanism they're giving you. So you better believe the poetry because that's the mechanism they're giving you for why the Earth doesn't fly out of the solar system. So don't tell me it's just poetry and it's just euphemisms and, whatever. They're actually telling you. And you say, well, that's just an analogy. An analogy for what? What does it mean? What is the analogy of warp time for? If gravity is warp time, that's what prevents the Earth from flying out of the solar system. But it turns out time is just a number line, or what they call a coordinate or dimension. Fine. Then you're talking about a mathematical concept preventing the physical Earth from flying out of the solar system. And so on the one hand, they say, well, this is just a way of speaking. We can't put our equations, our numbers, into regular words. Yeah, you can't. I know you can't. And that's why are you even trying? Why are you trying to explain to the common man out there, that how this universe works? It works through this depression called space-time. When you call their bluff, they say, well, that's just a figure of speech. And we don't do that anyways. It's not part of our job. What we do in our line of work is we do equations. Well, if you do equations, stay with your equations. Don't bring them into physics. Don't tell me that you understand how this universe works and that we have all these depressions in space-time out there in the universe. So it's one or the other. Either you do know or you don't know. If you don't know, shut your mouth. Don't get into physics. Don't tell me that you know how this universe works. And so this guy continues and he says, no one thinks that curved lines of isobars drawn on a weather map or the longitudes and latitudes drawn on a globe represent anything that is physically real. No, those are not real because we're not using those longitudes and latitudes. We're not bending them to produce gravity, a physical thing. That's a description of the Earth. These people are saying something totally different. They're saying that they're warping the number lines, and that is why, the Earth doesn't leave the solar system. So that's a little different. And of course, this guy leaves them off the hook. He says it's okay that they use all this stuff. Why? Because he doesn't understand that that's where the problem is, in the language. These people are giving you a physical interpretation for gravity, and they're saying it's warp time. And this fellow just leaves them off the hook and says, well, that's okay. He does it as well. He doesn't tell you what the ether is. He says, well, you don't know what the ether is. It's that flow, flows. Fluid that flows. Yeah, so he's in the same boat. They're all in the same boat because they don't know where space stops, and they say, well, it's infinite. No, if it's infinite, it's not an object. And if it's finite, you got to tell me what's on the outside of it. And so you can't have it both ways. And yeah, when you realize that space is a concept, it stands for that which doesn't have shape. Now we're okay, because it's a concept, and every object, every atom has this as a backdrop, okay? The nothingness of space. Then you can understand it. As long as you start talking about infinities, which belong really to math, you're never going to make sense of it. Okay, and here we have good old Stephen Hawking, and he says what space-time is. He says, it's often helpful to think of four coordinates of an event as specifying its position in a four-dimensional space called space-time. So he's saying what? What is space-time? A four-dimensional whatever, right? And then he says it's impossible to imagine a four-dimensional space. Yeah, so on the one hand, he doesn't realize he's saying it's four coordinates. It's not even dimensions, it's coordinates, because that's all they have in mathematics, coordinates. And so he's trying to imagine four coordinates out there, and he's not going to imagine them because that's a concept. You cannot imagine, you cannot make an image of an illustration of four coordinates, perpendicular to each other. Okay, it's just impossible. And so, yeah, he doesn't realize why he cannot imagine it. So poor Stevie, he had no clue whatsoever. Again, just a mathematician, and all these people have very little understanding of physics. What they know is a lot of equations, but what they don't know anything about is physics. For physics, you need ordinary language, ordinary speech, the everyday language to be able to explain something, not numbers. We don't use numbers in physics. You got to explain a mechanism. You can't explain it with numbers or equations. Okay, so another fellow brings up, he says, you recently suggested that the fundamental threads making up everything possess the properties of invisibility and intangibility. Yeah, exactly. That's exactly what we're proposing. We're saying that the thread, right, in the rope, intangible and invisible. In fact, very simple. If we take the pencil again, let it go, something is pulling from it. Like we said in the past, every atom here is connected to every atom of the earth. The closer it gets to Earth, the more the ropes fan out. That means that acceleration of gravity is just more and more fanning out of the ropes. That's all it is. A very simple mechanism. Kindergarten stuff, by the way. Okay? And so he says, he said, but how can they pass through each other? Again, tangibility is what gets all these people. They're talking about intangibility. How can they pass through each other? I cannot understand that. I do not accept it, because every day, in everyday stuff, we can't pass through objects. And so he's asking, how does this work? He says, however, doesn't your jump rope analogy that I use to explain the mechanism of magnetism involve swinging threads around both north and south poles? Yeah, either pushing away through clockwise, counterclockwise collisions, or attracting through both threads, swinging clockwise and briefly intertwining. Isn't that a logical contradiction? Okay, so I have said this in the past. I'm just going to go briefly to answer this gentleman. And so this is the answer for him. Tangibility comes when you have many threads, okay? In the case of the electron shell, all those electron shells are made out of tons of threads, which they probably even have several layers for all we know. But even if we have a single layer, what you have is now a surface for the first time, okay? And that's why the atom is under certain conditions. If you send an atom against another, or a neutron against another atom, you have a totally different situation. We're not going to get into that right today. But all I'm saying is tangibility. Why an atom cannot normally go through another atom is because it has a surface. What is a surface? It's the electron shell. What is the electron shell? Many, many, many gazillions of threads weaving the surface of that shell. And in the case of magnetism, which is the one on the right, what you have is a wall of threads moving around. It's a wall. It's not just one thread. We're talking about a wall of threads. And now it doesn't even really push completely. What it does is go through the other, because it's going at great speeds. It's swinging around at great speeds. It goes right through, but it creates a certain friction that the other magnet senses, the threads of the other magnet sense. And with tons of these moving around like a paddle wheel, of a riverboat, what you have tons of these moving around, and that's why they create that push mechanism. Because what's actually happening is you have tons of threads that form walls, one wall right after another, as a paddle wheel of a riverboat. And what it does is go through each other, but creates this tenuous friction, which only gets stronger and stronger the closer two objects are together, because now you have more and more walls of threads going through each other. Okay, so that's why it hits and pushes each other away. One thread can go right through another, and there's a very, very imperceptible friction there, perhaps. But when you have walls, now there is a more important friction, and if you have many walls turning around, now you have more friction, more pushing, right? And the closer the objects are together, the more threads, because you have more atoms closer together, they're swinging around, you have more and more threads. The closer you try to get the two magnets, the more they try to push each other away. The farther away, well, now the threads, again, can go through each other without causing attraction or repulsion. So that's the notion. The notion is the quantity of threads form these walls. Once you have the wall, now you can figure out why they push or why they attract. Okay, so that's the general notion of that. Another fellow says, are these supposed ropes intangible, or are they physical mechanisms? You can't have both. Well, the first thing is they're not mechanism. The rope is a mediator, a thing, an object. Okay, you shouldn't confuse that with a verb called mechanism. Okay, mechanism is what the ropes do. Okay, that's the first issue. So he says, you can't have both. Well, physical mediator has nothing to do with tangibility or visibility. An object is that which has shape. There you see it at the bottom. Physical, that which has shape. Okay, so physical means that it has shape, not that it can be touched or seen. Okay, so no experiment, therefore no experiment, meaning eyes or hands, right, can determine an object or a thing, a mediator that is invisible and intangible. Okay, so plays no role. The tangibility plays no role in this matter at all whatsoever. Okay, and then we have another fellow, and he says the following, talks about the gut. So this is not a grand unified theory, meaning, the rope can serve, where did I put the rope here? Rope serves both for light, the torsion along a rope, okay, between two atoms, and then it also serves for gravity, because all these ropes are connected, like from the pencil. Every rope from every atom here is connected to every rope on the earth, and so the same rope that where you send light from one atom to another, that one also serves for the gravitational phenomena, meaning, as the pencil falls, the ropes fan out. So it's essentially one mediator for two mechanisms. One is gravity and the other one is light. Okay, so that is the gut, the grand unified theory, otherwise known as TOE. The theory of everything. And here, just to clarify, right? Where is it here? The difference between the gut versus the TOE, just so that people are aware. Any model in particle physics that merges the electromagnetic weak and strong forces, the three interactions, into a single force at high energies. Okay, that's what the gut is. And for us, it's all the same. Gut or TOE, it's the same thing, because the theory of everything. Why? Because a theoretical framework revealing a deeper underlying reality unifying gravity with the other three interactions. And that's what we're saying. We're saying there are no three interactions. There's only two. There's only push and pull. Those are the only things we can imagine, the only forces we can imagine. And so light is a push and gravity is a pull, and rope can push and pull. That's one thing good about a rope. It can if you torque it, it causes a little pressure at the end. And at the same time, it's pulling on whatever's at the two ends. So ropes can push and pull. Particles can only push, okay? And that's why the rope unifies the gut. And so this fellow says, I know he talks about some other stuff that has no relation to this. I don't know what he thinks the gut is, but he says, gut ties all conspiracy theories together into one. So he went into politics, overarching conspiracy theory that explains how our minds are controlled and by who or what and for what purpose. So I don't know what this guy knows about the grand unified theory. To assume that the puny human mind can fully comprehend the majesty of God's creation is bordering on blasphemy. Yeah, human mind can comprehend it. We can comprehend. If God came here today and told us how gravity works, how light works, we would understand. We are intelligent enough to understand what God is telling us, especially if it's baby stuff like gravity. All we had to do was make visible the invisible ropes, and then we understand gravity, we understand light, we understand why the earth doesn't fly out of the solar system, we understand why this pencil falls to the floor. And we understand what light is because, it's just a rope conveying a signal known as a torsion. And so we would understand. If God came down here and explained it to us, we'd say, okay, I understand what you're saying. Now, God, he knows everything. He tells us. We have the intelligence to understand him. There's nothing a human cannot understand. But see, they put it out of your reach and say, well, Father Universe speaks a different language than humans, and we'll never understand him. All we can do is search and try to find and never find, really, right? And that's the same thing he's got in his mind. He's saying, I leave it up to God. I put it beyond the reach of everybody. Nobody can understand what God created, and we have to leave it like that. We have to leave it without understanding it. Well, that's okay for him, not for intelligent people, okay? We see through the glass darkly and are not gods. Yeah, we are the gods in the sense we're mortal, and that's the only thing we're not gods of. And we're also mortal as a species, so we're about to die. We're approaching extinction. So we're not mortal. We're mortal both individually and collectively. So in that sense, we're not gods. But we're gods in the sense that we have the intelligence of God. God has no more intelligence than us. Okay, so sorry, God is not more intelligent. We are gods in that sense. We are the caretakers of the Garden of Eden. Okay, let's move on to the subject matter today, the prime one, which was teleportation. And so what is teleportation? Well, it says that you can move things around, by remote control. Kind of, it just happens. And it moves from here to there. And they call it teleportation because it just moves. And apparently nobody knows the cause, okay? And here, we'll start with this one. I don't know if you've ever seen this, but it comes from Popeye. And here's our first proof, evidence of teleportation. And here you have Bluto, and he's going to do some action at a distance. And suddenly, you have this wall move upwards. And they all go through, all the Sinbad and his 40 thieves. And when poor old Popeye tries to get in there, well, he's upset because he doesn't know the trick. He doesn't know how it's done. And all he had to do was open sesame. Okay? And then the wall would have opened up. But he didn't know that at the time. Okay, so it took him some time to understand that. Okay, so now you know that's teleportation and action at a distance and remote control. All that's been around, at least since the days of Popeye, believe me. Okay, but here we do a teleportation here. Here's in the city of New York. A magician does this, okay? And here it is. Let me show you this. This is the trick. And the guy's going to put that thing over these 4 people, and suddenly the 4 people appear somewhere else. Pulls the string, they disappear here, and they appear over there. Okay? Now, how's that for a trick? Okay? So yeah, this is a magic trick. And people say, was that real teleportation? Was that quantum teleportation or general relativity teleportation? No, that was a magic trick. It was a trick. They fooled you, okay? Maybe it was done with mirrors. Who knows? Magicians don't tell you their secrets. You got to find out for yourself. You got to figure it out yourself. Okay, so no problem. That's a magic trick. Does teleportation occur in reality, or only in cartoons and in under magicians tricks? Well, let's find out. Let's go to some reliable sources. Here's what the National Science Foundation says: is teleportation possible? Yes, in the quantum world. And says, while human teleportation currently exists only in science fiction, teleportation is possible now in the subatomic world of quantum mechanics, albeit not in the way typically depicted on TV. In the quantum world, teleportation involves the transportation of what? Information. So they're teleporting what? Information, a concept. They teleport concepts. That's great. Rather than the transportation of matter. Okay, so what are mathematicians into? They're into concepts. They always transfer concepts. They move concepts around. They use mass to attract stars, move them around, whatever. They deal with concepts. And teleportation is not an exception. They're saying teleportation happens, but what we're teleporting are concepts. Okay, so keep that in mind. We're not transporting or teleporting matter. What we're doing is transporting, teleporting, moving concepts. Okay, so here we have one. You might say, Bill, you just pulled one out of there, out of nowhere. Okay, here's a physicist, so-called physicist, mathematical physicist, and he's going to explain teleportation to you. Okay, so I did the blah, blah, blah in the background, but I imitated every word that he said, okay, and it's also written there, so try to read as fast as you can because these videos go quite fast. Here it goes. Give me a second here. Here it goes. Listen carefully. The good news is that teleportation is real. The bad news is that at the moment we can only teleport one atom at a time. And the record for teleportation at the moment involving one atom is teleporting over a distance of 1,400 kilometers of the Chinese satellite called Mathphyz. They teleported an atom from the ground up to the satellite, so the actual atom never moved. All you do is take one atom and measure its exact properties, and in the process of measuring its properties, you actually mess it up and lose that information. But you can transmit that state to the spacecraft, and you can recreate an atom exactly the same. Okay, so they don't transfer objects. They don't transfer the atom. What they do, they mimic or they reproduce the properties of that atom in another atom. And this one is destroyed in the process. And the other one over there now is the new old atom. So they claim that's called teleportation because they transferred the properties of one atom to another atom, which is now identical to this one. I don't know how that can be because there are two different locations. So at least one property is not the same, which is location. And I think it's a very important property here, especially if the atom is at the other side of the universe. I mean, if they say teleportation occurs instantaneously, and you have one atom on this side of the universe, another one on that side of the universe, and you just transferred the properties over there. And I guess now the monkey over there is dressed in the same suit as the monkey over here. Well, that's the same monkey as this one, because one thing is different about him, and that's location. Okay, so that property was not transferred, the property of location. Okay, here's another fellow, and his name is not Mike Tyson, it's his brother. Neil Tyson. What does Neil Tyson say? Well, he says that forget about teleportation. Teleportation is easy. But he hopes one day to have a wormhole and he can slide through this one-dimensional number line and be at the other side instantaneously. It's a teleportation using the wormhole as a mechanism. Okay, so listen to the man here. We're going to hear it from the horse's mouth. Here he goes. Teleportation? I cannot begin to tell you how game-changing that would be. What you really want is the power to open a wormhole anytime, any place. On Star Trek, they go into the transporters and beam somewhere. If they had Rick's power of portal, you just open a portal, step through, and you are where you need to be. You just step through a wormhole. I can't wait. The future when we have wormholes. The day we have wormholes, you won't need airports. So this other fellow was saying that these people are just talking about euphemisms, figures of speech. What's this fellow talking about? What's Neil Tyson talking about? He's saying that you can go through a wormhole to another universe instantaneously. Just get into the black hole that serves as the wall, the interface, and you enter there, you go into the wormhole, and you arrive at some other place instantaneously. So we have this teleportation through the wormhole. Are these people for real? Are they talking for real? And if they're not talking for real, why are they putting this nonsense on TV, in the media, to try to convince people that they know what they're talking about? If it's not real, then what is all this nonsense? The other fellow says you can only transfer, properties. This fellow says, no, I'm going to be transferred. My body is going to be transferred through the wormhole, teleported to another universe. So what is it? Is it just concepts, or are we transferring objects like human beings, teleporting like, Star Trek shows? You go into a teleporter, they disintegrate you here, and you appear integrated somewhere else. So let's find out. Are these people talking for real, or are they talking about, where they go to school, Hollywood University? What is this? Is this science? And yeah, this is what they feed the public. And so a lot of people believe that this is real. And so why are these people allowed? They should be censored on YouTube for, passing false information. Okay, they censor us for much less. Wonder why they don't censor these people selling garbage to the public. Okay, these people are committing crimes against humanity. That's what they're doing. Okay, so here's another famous site. It's called Minute Physics. Most of you probably heard of it or know about it. And these people say that if you're transferred, like Neil Tyson said, you transfer instantaneously somewhere else, whether through a wormhole or just teleport or whatever inside the room, is that other fellow you, or is that another fellow? Because, we're transferring all your properties, all your feelings, your headache, your pain, your love, everything that you can think of, all your concepts in your body, transferring your concepts to this other fellow. They have to disintegrate you, because otherwise we'd be creating another you. There'd be two yous to, clone. And so they have to destroy you, and they create you over there with all your properties, whatever that is, right? All your feelings, whatever. And now you're over there. And the question is that you, the same you that started, where the experiment started. And listen to it. Here it goes. He goes quite fast, so you got to pay attention. Here it goes. When a transporter dismantles every atom in your body and reassembles an identical arrangement of atoms somewhere else, perhaps the disassembled you actually dies, and the reassembled you is actually a new being that just thinks it's you. And if they simply hadn't dismantled the original you, then there would now be two yous in the universe. And which is really you? You or the teleported you? Are these people kidding me? Is this science? I mean, all this is put out there as if it were science. And this other fellow says, they're talking about euphemisms. They're, presenting figures of speech. They're doing analogies. It's not the real thing. These people actually believe all this stuff. And if they don't believe it, why are they presenting it as science? I mean, this should not be in a scientific form. This should be, and they're writing papers on this, scientific papers, in the scientific literature, as they call it. I mean, this stuff is okay for Hollywood. I have no problem. They make a movie out of the stuff and say, hey, this is fantasy, this is science fiction. We love it. Yeah, I love it too. Go back to the past, see your grandfather, all that kind of stuff. I love it. But to think that this is real, like these people are presenting it in science forums, writing papers in the scientific literature, that's something else. That's totally something else, especially when they claim that they know how this universe works. When you challenge them, they say, well, you took it too literally, Bill. Yeah, physics is literal. It had better be literal. If you say there's a wall blocking the Earth from flying out of the solar system, you mean exactly that. And you can make an analogy and say, well, the wall is like the wall of Berlin, the Berlin Wall. Okay, fine, no problem. You can say something like that, but you cannot say it's time. It's like saying, like we were talking the other day about frame dragging. The Earth drags time around. And what analogy am I going to use? I can say that the dog drags my clothes around. Got him with his teeth and drags my clothes around. And we can say it drags them around like a tugboat drags a ship. Because one tugs and the other one tugs. We can all see that. We can see, the similitude between the two scenarios. But when you say the dog drags seconds around like the Earth drags time around, what is the analogy? What does that analogy stand for? What is that idiocy? Especially when it presented in a scientific forum. So that is nonsense. That is poppycock to say that. And so they don't say, well, the Earth doesn't drag time around. What they say, it drags frames around. It's a frame dragging mechanism. And people say, oh, that's so scientific, it's over my head. And what they're saying is that the Earth is dragging time around itself. And so I don't know. If you're satisfied with that, well, God help you. Okay, so what's the problem with all this teleportation and wormhole instantaneous transfer across the universe? Well, what's wrong with it is this. Here we have, and I'll just illustrate it, okay? We have a magician, and he's going to cut the lady in half. In fact, there's no magician here. It just shows that the lady is cut in half, right? And then, curtains closed, curtains open, and the girl comes out, and she's in one piece. And so it's a trick, right? It's a trick. Now, I don't recommend you do it at home with your wife or your girlfriend. Take the saw and cut her because you might really do some damage there. You need to know how the trick is done. Then you can go in there and saw, the lady in half at home. But you need to know the trick, okay? And that's the issue. And so here, let's look at this trick, this magic trick. Goes more or less like the first one there where they had that levitation, teleportation, from one box to another of all these four people. Well, this is something similar. They're going to cut the lady in half and watch it so that you see what we have to answer, what in terms of teleportation, what the issues are. Here it is. Okay, we all see it. Saw the lady cut in half. She's put back into one piece. We have a description. We say, okay, this is what happened. Do we know why it happened? How the trick was done? So when you say teleportation, same thing. You say, okay, it was over here, and suddenly it appeared over there. I don't care if it's an atom. I don't care if it's the properties of the atom, a concept. We don't care. What was the mechanism? That's what we want to know. How was it done? How did it happen? And these people say, it happened. Okay, yeah, the lady was cut in half. It happened. But don't do it at home because you don't know how to do it. You don't know the trick. Like Popeye, he didn't know how the trick was done. How did Bluto, Sinbad, how did he pull that wall up by saying, open sesame? So this is what we need to answer. And these people are not giving you the mechanism. They're just saying it is so. But that's because that's their interpretation based on the particle model. That's why they say, well, this particle is over here and suddenly we saw it over there. Well, did you? Is that a correct physical interpretation for teleportation? Were the properties of this atom transferred over there? Well, first, we can't transfer properties, so that's not a mechanism. You can't say you transfer properties. And if you transfer the atom from here to there, what was the mechanism? How did you do that instantaneously? How did this atom suddenly appear somewhere else, destroy here, and appears here? And again, you got to give me the mechanism. Without a mechanism, you get absolutely nothing. And that's what we're missing from mathematical physics. Okay. So here we have, for example, here's for the lady cut in half. I want to show you what the difference is between a description and an explanation. Some people don't understand that. Here it is. The one on the left, it's, the description that we get from the mathematical establishment. The guy said it happened, and gives you an equation and says A is head, B is torso, and C is legs, right? And then 20 strokes of the saw, 10 seconds, 2 pieces, 2 curtains close and open. And once it opens again, the lady's in one piece. That's a description. So far, you haven't told me how it was done. Physics, on the other hand, gives you an explanation of how it could have been done. These are different theories of how the magician did the trick. In one case, the lady is below the level of the saw, underneath the stage, for example. In another case, it's 2 girls, okay, one with the legs, the other one with the head. And another one, same thing, but you can see they're in different positions. So these are different theories of how this trick was done. And that's what we're asking, for the mathematicians to explain when it comes to quantum mechanics teleportation. Tell me how the trick was done. Don't tell me it is so, because all you're saying with that is that you're interpreting that under the particle hypothesis. So you say, I had an atom here. Well, did you have an atom there? Did you locate it? Do you know for sure that atom was there? And if the properties ended up over there, you can't say the properties were transferred, because that's even worse. You can't transfer concept. And if you transfer the particle, how did you do it? Just tell me how, what the mechanism is. Okay, and that's where we fail with teleportation, as well as all these magic tricks. Magic trick, fine. You got to figure out how the magic trick was done. Especially cutting the lady in half. Don't do it at home, except in the presence of a relativist. He'll tell you how it's done. Okay, so here are the conclusions. The atom is already there, okay, in teleportation. That's what they're saying. Okay, so it's not like there was a transfer of atoms. They're saying there was already an atom at the satellite and another one here on Earth. And what they're going to do is transfer the properties from this one to that one, okay? So they're transferring the properties, right? And then they claim there's no teleportation of matter. Okay, it's the properties that they're going to transfer, okay? And then again, Tyson says, hey, I'm waiting for the day when we transfer matter, like me. Human being from here to there, like in Star Trek. And then, again, we can't teleport concepts, but that's what they claim that they're transferring, they're transporting, they're teleporting, right? They're sending concepts from here to there. They're saying the properties are being transferred, not the matter. Okay, and so, we have a problem with that. And then we have another problem when it's instantaneous. They say from here to there, it happened instantaneously. Because if I walk over there, that's not teleportation. That's normal walking. No. For it to be magic, for it to be, ooh and ah, well, then you have to transfer the object over there from one location to another instantaneously with nothing in between. That's teleportation. Okay, and so, it's an instantaneous transfer, essentially, because they're disintegrating you here, like at the teleporter in Star Trek. They're disintegrating your body here and reconstructing your body elsewhere. And hopefully, as they disintegrate each atom here, that atom is assembled over here. So that atom is being transferred instantaneously. Otherwise, this one wouldn't be disintegrating at the same time that this is integrating. Okay. And then the question is whether you can do that through a wormhole. Wormhole is one-dimensional number line. They call it a dimension, coordinate, or something like that, vector. They use all these words, meaningless words. No, it's a number line. And what they're saying is, and by the way, the wormhole, it's called Einstein-Rosen bridge. It's not a bridge at all, but they use these words such as bridge, and people think, oh, it's a bridge. Yeah, I understand. It's like a tunnel. No. The wormhole is a number line. That's all it is, a one-dimensional number line. And when you go through this one-dimensional number line, what are you going through? Is this a tunnel, three-dimensional tunnel? How do you get any matter through there? Okay, so it's absolute nonsense to begin with, but that's another version of the, of this teleportation. It's through the wormhole. You are here and suddenly you're in a different universe through the wormhole. That's the mechanism. And again, there's no mechanism there because they have no mechanism for how you were transported through a wormhole from A to B. They have no mechanism. They just show you, you know, the rabbit going through the hole. That's all they show you. And they say, well, what speed am I going through the hole? And it turns out you appear at the other side instantaneously. So it's like you even beat the speed of light. Okay, so the million-dollar question, that's all we're interested in. By what mechanism did the mathematicians, transfer concepts? What is the trick? That's what we wish to know. And hopefully one of you fellows will be able to answer that question for me by next week.